Let's start the new topic, RMS values of voltage V and current I. So, I am recalling you some equations of voltage and current which we have discussed in the above theories. So, the equation for voltage what you are using was of the type V is equal to Vm cos omega t for AC voltage. Similarly, the equation for electric current I, what we have used, was of the form of Im cos omega t plus or minus delta. And here the voltage and current are actually changing with respect to time periodically. And hence they are named as AC current and AC voltage. So in this condition, to know the values of voltage V and current I, we can consider voltmeter connected to the circuit and the current meter, or we can say it is named as ammeter. So these are the actual instruments to find out the value of voltage and current in the circuit, but it is not possible to measure voltage or current in the actual type of conditions like the AC circuit. If we try to find out the average values of AC voltage or AC current in this condition, so here the value of AC voltage will be 0, and by this the value of average current will be 0, because it is the function of sine or cosine. But we know that the average value of sine or cosine function over the time interval. If we see about voltage V, that is equal to Vm integration 0 to t, and so I am dividing with the time interval. Here cos will become cos omega t into dt. Now if we simplify this equation, then it is Vm over t sin omega t over omega t from 0 to t. So this value will be 0. But in practice, the specially designed voltmeter for voltage and the specially designed ammeter are used to measure voltage V and current I. Now this meter will give not actual value, but the value is of the type root mean square value. So here by the use of above meters, we will get the root mean square values of voltage V and current I. So here the root mean square stands for the RMS values. Similarly, if you want to write down a definition of such a root mean square, then we can write it as root mean square of a quantity means the square root of the average of the squares of that quantity. So this is the definition of root mean square. Now suppose you want to find out the root mean square value of voltage. Then for voltage you are having the values of the average of velocity means average V, its square, and finally the square root what you are finding. So such values is referred as RMS voltage, or it can be written in this way VRMS. So let's try to find out the RMS value of voltage as given by V is equal to Vm cos omega t. And so average V square is given by average Vm square cos square omega t, that is equal to, now here Vm square is having the same value for average or normal. So I am taking Vm square outside from the bracket, and now the simplification of cos square omega t is 1 plus cos 2 omega t divided by 2. And so I am giving this 2 in the denominator of each of the numerator term. So that is equal to Vm square inside the bracket 1 by 2 plus cos 2 omega t divided by 2, which is equal to Vm square into bracket 1 half plus Vm square by 2 into 1 over t integration 0 to t cos 2 omega t into dt. Now we actually know the value of this second portion. The value of this integral 1 upon t integral 0 to t cos 2 omega t dt, that is equal to 0, as we have performed in the starting of this theory. So we are substituting this as a 0 value. So after the addition there will be no term, and the average value of 1 half is the 1 half itself, and so the average value of V square is equal to Vm square divided by 2, and so the RMS voltage Vrms is given by just providing under root to this average square. So this is under root of V square average, and that is equal to, you just apply the square root on the right hand side of above equation, then square root of Vm square is Vm and the square root of 2 is as it is, and this is the RMS value of voltage. And similarly I can write down the RMS value of current is denoted by IRMS, that is equal to Im over root 2. But here you should understand what is the Vm and Im. Here Vm and Im are actually the maximum values of voltage and current respectively. Now we will start the new topic, series resistance.